name is Mutra Enoch, and we are going to revise together pH 110 and linear momentum. And the question reads: a bullet of mass 15 grams and traveling at the speed of 600 strike a block of 3 kg, which is suspended by a string of the length 4 meters. The bullet goes through the what? The block in a very short time, and the center of gravity of the block is found to rise a vertical distance of 10 centimeters, as shown in the figure. What is the speed of the bullet just after it emerges from the block? So what you should understand is that we have two types of what? Collision. So what was happening here? It was collision. So this bullet struck the block that was at the rest. It was suspended and it was at rest. It making sense? Meaning the initial velocity of this block was what? 0. And then after this bullet struck the what? The block, it penetrated. That simply means that the type of what? Collision that you are dealing with is elastic collision. The type of collision where two objects, they move with different what? Velocities. Now we have been given the what? The height of 10 centimeters. So before we start answering, what you have to do is that you have to convert all given masses. You make sure that they are in what? Kilograms. So we are going to start with what? With the bullet, converting the mass of what? Bullet, or collecting what? Data of a bullet. So data of a bullet. This is for a bullet. So we know that 1 kg is equivalent to what? 1,000 grams, not 1,000 grams. And you have been given the mass of the bullet to be 15 what? Grams. So I'll put X there and then gram. They are going to cancel. So when you multiply there, you're going to get 1,000 X is equals to 15. So we are going to divide both sides by what? 1,000. So 1,000 over 1,000. So when you divide 15 over 1,000, what are you getting as your mass in kilograms?
0.015.
So 0.015 kg. So this is the mass that we are going to use for a what? For a bullet. And then they say this bullet was traveling at the speed of 600 meters per second, meaning this was the initial velocity because the bullet was in what? In motion also. So our initial velocity of the bullet, so I assume to say this bullet is object A, and then this block is what? Object B. Does it make sense? So that is initial velocity of A, which is the bullet, which is 600 meters per what? Per second also. So from there, that is the data that was given under the what? Under the bullet. Now, what about the block? So the question says, after this block strike the what? After this bullet strike the block, this block, it emerged or it raised and it made a height of 10 centimeters. Now, the height is supposed to be in what? In meters. So we are going to convert that what? That 10 centimeters to what? Meters. So data for a block. So we know that 1 meter is equivalent to 100 what? Centimeters. So that is 10 centimeters, the one that you have been given. You put X, since you are looking for what? Distance or height in what? In meters. So that one will cancel. You are going to get, when you cross multiply, 100 X is equals to what? 10. So you are going to divide both sides by what? 100. So over 100 over 100. So what is the value when you divide 10 over 100? What are you getting?
0.1.
So 0.1 meters, no so. And then what we are going to do is that since this block was at rest, it was suspended, meaning the initial velocity of this block is what? 0. So initial velocity of B, meaning the block, that is 0 meters per what? Per second. Does that make sense? Now, apart from that, since this block it moved a certain what distance or height, we can find its what? Its final velocity. So the final velocity can be calculated by principle of mechanical energy. But I'm going to show you the short formula that you are going to be using whenever the angle is not given. So you say final velocity. So final velocity of block B is equals to the square root of 2 times acceleration due to gravity as what? Height. So final velocity of a block is equals to square root of 2 times acceleration due to gravity, that is 9 point what? 9.8. 9.8 times the height that you have converted is 0.1 meters. So final velocity of the block is equals to, what is the figure when you multiply 2 times 9.8 times 0.1? 1.96. If you square root it, what are you getting?
1.4.
So 1.4 meters per second. So this is the final velocity of the what? Of the block. Now, you have to bear in mind, in the question, some people can get confused. In the question, there is what? Length. Some people can utilize this length, but in that case, this length is not going to be what? Used. You can only use this length when the angle is given, where the height is calculated by this formula. Height is equals to length times 1 minus cos what? Theta. Does that make sense? Whenever the angle is given, that's when you utilize the what? The length. No so. Now, here another thing changes. What about how do we calculate the final velocity of a block when the angle is given? So we say that final velocity is equals to square root of 2 times g h. Now in that case, this h, we know that t is that thing also. So which is final velocity is equals to square root of 2g. What is height? Replace it with this thing. So which is length 1 minus cos theta. So please, this formula is only used when the angle is given on the ballistic what? Pendulum. Is it making sense? This one I'm emphasizing. This formula is only used when the angle is given on the ballistic what? Pendulum. And then this one is utilized also when the angle is not what? Given. So we can proceed now into what? Calculations of our solutions. So from there we can now proceed in the calculation of what? The final speed. So they are saying what is the speed of the what? Of the bullet just after it remains, meaning we are calculating the final velocity of the bullet. So we can proceed. So after you have collected your data, and then another thing is that we have been also given the mass of the what? Of the block to be what? 3 kg also. So I'll just say mass of the block, which is P, is equals to what? 3 kg. Also, Now from there, to find the final velocity of the bullet, we are going to use conservation of momentum, linear momentum also. Now, since that bullet penetrated the block, meaning it was undergoing the type of collision called what? Elastic collision also, where it means that two objects, they are not moving with the same what? Velocity also. So I'll say mass of an object A, that is the bullet, times what? Initial velocity of an object what? A, which is the bullet. We are having two objects. The bullet and the what? And the block should be added with the mass of object B. In that case, we are assuming object B to be a what? Block. So that is initial velocity of a block is equals to the mass of the bullet, which is A, times what? Final velocity, plus mass of B times the final velocity. So from there, since we know that you have collected your data, you can just replace everything there. So that is, what is the mass of the bullet or object A? So the one that you converted, that is 0.015. Also, does it make any sense? Times the initial velocity was what? 600. So from there you add. So mass of an object B, which is the block, is what? 3 times what? Initial velocity, that is 0, is equals to mass of an object A, which is the bullet, is 0.015 times, we are looking for the final velocity of the bullet after it emerged also. So that is VA plus mass of an object B, that is what? 3 times the final velocity, which we calculated to be what? 1.4. So from there, what is 0.15 times 600? 9 plus, so 3 times 0, that is 0, is equals to, so you're going to obtain 0.015 VA plus, what is 3 times 1.4? 4.2. Now from there, this is just 9 plus 0, you are getting 9. Is equals to 0.015 VA plus 4.2. So collection of like terms. So the numbers are similar, so that is 9. So when this positive 4.2 crosses the equal sign to become negative 4.2. Also, so from there we are going to remain with 0.015 VA. So what is 9 minus 4.2? 4.8 equals to 0.015 VA. Divide both sides by 0.015 over 0.015. So you are getting your final velocity of a bullet will be what? 320 meters per second. So this is the final velocity of the bullet after it emerged the what? The block. So if you are finding this video interesting, don't forget to like, also to click on the subscribe button. Thank you so much.